Okay. So I want to go through some problems that we've seen in Math Excel, and also some problems that parallel to that come from the in-course exam. Okay. So this exponential thing, this looking at relationships in charts and tables is a big component of that test, or has been in the past. Okay. So I want to do this process. So this was question 9 on 7-6, okay, which I've opened up until tomorrow night if you want to keep working on that. If we read this problem, it says in 2000 there were 1,000 cell phones, okay? 2000 there were 1,000 cell phones. So the number of cell phones increased by 20% each year after 2000, okay? It wants us to do three things. It says make a table of values to represent the situation. It says you need to determine if there's a common difference or a common ratio. And then the last thing is to decide, based on that, is this thing linear or exponential? Okay. And what I want you guys to see here and recognize what's being demonstrated is that this question, obviously it walks us through it, ABC, right? We're going to do this problem and then we'll go to an end of course exam question, and all it does is ask you for the equation. But to get to that, you need to do A, B, and C here. Does that make sense? Okay, so we're kind of walk through this. Okay, so first thing, whenever we talk about these types of scenarios, when they give us a certain date in which something is to be recognized. So the date is 2000, and we're recognizing that there's 1,000 cell phone owners, okay? What that means to us is that at what we call the initial time, okay? No time has elapsed yet, okay? So when I'm looking at this situation, it says every year we gain 20%, right? So from 2000 to 2001, at the 365th day, that makes it 2001, that is where we would see 1 year as our X value. Does that make sense? Okay. And then 2 years will be from 2001 to 2002. So what I want you guys to see here is that when I say this 1 here, that actually represents the year 2001. This 2 represents 2002. This 3 represents 2003. Does that make sense? Therefore, this would represent 2000, right? That's the start of this recognizing this data. Okay, so when your year is 0 or your time is 0, we call that an initial, okay, an initial amount, an initial time period, that kind of thing. Does that make sense? Okay, so at the initial time, how many people did we start off with cell phones? 1,000. Okay, now it grows by 20%, right? So how do I figure out then how many people are going to be in year 2001?
Multiply 1,000 by 0.2.
Okay, I'm going to multiply 1,000 by 0.2. Okay, and that's going to give me what? Okay, 200. Okay, so now what do I put 200 in that box? Okay, so I'm going to have 1,200, right? Okay. Now, from 2001 to 2002, it grows by another 20%. So now I multiply the 1,200 by 20%.
That's what I did.
Okay. So now if I take the 1,200 times 20%, 240. Okay. So then I'm going to add the 240 to the 1,200. So it'd be 1,440, right? Okay. Then I'm going to multiply that by 20%.
Can I fix that?
So again, 288. So what's 1,440 plus 288?
Mr. Fake, can I move up?
I messed up. 17.
1728? Okay. Okay, so those are the things that in Math Excel, those boxes are blue in Math Excel, we got to type those numbers in, okay? Now, not everybody has 20%, not everybody starts off with 1,000, okay? But whatever you start with, you multiply by 20%, get you the next number. Add those together, add 1,000 and that next number together, okay? So, there's another way of doing that. There's another way of getting, because I think this is the way, and this is the way I think most people do this because it's the way you were probably taught in like the 5th grade, 6th grade, where you guys did taxes. If I buy something for like $45.23, but there's let's say a 7% sales tax, don't you multiply that by 0.07 and now add that number to the 45.23? And that's how much I'm paying at the cash register, right? Okay. That's essentially what we just did. If I start with 1,000, multiplied by 20%, gets to 200. Now I take the 1,000 plus the 200, right? Okay. But can I get the same thing? Because my users are 100% of the original 1,000, right? And then 20% of that original 1,000. So what's 100% plus 20%? 120%, which as a decimal is 1.2. So if I take 1,000 and multiply it by 1.2, does that give me the same 1,200 for the second block?
Yes.
Okay, so let's keep doing that. What if I take 1,200 and multiply it by 1.2? Does that give me the next block?
Yeah.
If I take 1,440 and multiply it by 1.2, does that give me the third block?
Yes.
Okay, so that's one way of doing it. Now, the reason I like doing it that way is because it allows me to see that going from the first cell to the second one, I multiplied by 1.2. From the second one to the third one, I multiplied by 1.2. To get to the third, from the second to the third one, or I guess it'd be the third to the fourth one, I multiply by 1.2, right? You guys remember calling that a common ratio yesterday? Okay. Now, if you went with the alternative to that, where you were taking, bless you, the 1,000 times 0.2, and then adding that 200 to there, you might not recognize right off the bat that 1.2. Does that make sense? But the way you can reckon, and this will always work, the way you can recognize that 1.2 is to take that green number and divide it by that blue number. Does that make sense? So if I do that, let's take the green number of 1,200 and divide it by the blue number of 1,000. Does that give me 1.2?
Yeah.
If I go 1,440, what should I divide 1,440 by? 1,200. Does that give me my 1.2? And I go 1,728, and that should divide by 1,440 and gives me a 1.2, right? So, and why are we dividing? Well, when I went from 1,000 to 1,200, I was multiplying, right?
Yeah.
So when I want to see if I go from 1,200 to 1,000, I would divide, right?
Yeah.
Okay. Yesterday, I think an example we did, if I scroll down to the examples we did yesterday, you can see maybe in these questions that it's easy to see that these were multiplied by 2, right? Easy to see we're multiplying by 2. Easy to see here that we're multiplying by 4. If you can't recognize initially what we're multiplying by, you can start with that one, start with the 12, and divide by the 3. The 48 divided by the 12. And that will then tell you what you were multiplying by. Does that make sense? Okay. That's why it's called a common ratio, because ratio is a comparison of two numbers through division. So we're actually comparing that number divided by 3. 48 divided by 12. 192 divided by 48. And that's where that common ratio of 4 is coming out. All right, so we got the chart filled in. We good with that? Okay. Now, yesterday, our chart was vertical, but it doesn't matter. This is horizontal. But the common ratio, because we're multiplying from one to the next, that's why it's called a common ratio. So we come down here and we find an option B says the common ratio is, and in this case, it'd be that 1.2, right? Okay. Now, part C says choose the correct one. Is this, if we have a common ratio, is this going to be the ask, is it linear or is it exponential? This is going to be exponential, okay? So a common ratio a common ratio lends us to or takes us to an exponential function. Okay, so common ratio means division or multiplication, right? That's kind of what we're talking about there. A common difference is adding or subtracting, right? And a common difference will take you to a linear function. Okay, so we've got a ratio. We're multiplying one y value by something to get the next one, okay? So that's a common ratio. So this is gonna be exponential. Now this question does not ask us to do this, but I wanna make sure we can do this, and you'll see the purpose here in a moment. Let's write the equation. Let's write the equation that this yellow scenario is determining. And every exponential, once we decide it's exponential, should be of that form, right? Okay, that's why we want to look at that common ratio and then fill in parts B and C so we can make the argument. Well, we know that this scenario, this situation, should be modeled by an equation like this. Okay, if we would have found a common difference, we would have known that the situation would have been modeled with something like that, right? That makes sense? That's linear. This is exponential. So we're going to start with y equals a times b to the x. Now, anybody remember what the b value is in this situation?
0.
I haven't heard it yet. It's the common ratio. Okay? So your b value here, all right, this is y equals, I don't know a yet, but b is 1.2. I'm going to raise that to the x. Okay? Now, how do I use my table to find A?
Like this one.
2 points.
All right, I'm gonna use one because that's an X, right? That top row is X's and the bottom rows are Y's. I've got an X and I've got a Y over here, right? So I could choose any one of these ordered pairs. You could use 3 and 1728. The math is gonna kind of stink compared to what we could use. I'm going to use this ordered pair here, okay? And this was 1,000, right? So I'm going to let y be 1,000. A is what we're looking for, and x is 0 in that case, right? What does 1.2 raised to the 0 turn into? 1. So I got 1 times a, right? So let's say a is 1,000, and b we said was 1.2, right? So let's write our equation. Y equals A, 1,000, times B of 1.2, and then times X. Does that make sense? I'll rewrite this as...
I was thinking of y equals a.
Right, so this has got to be exponential. Okay, so that's got to follow that form. So now let's just check to make sure this works. Let's see, because this is a rule essentially that should generate these ordered pairs. Okay, so let's see if that happens. So we'll clear all this out, and I'm going to type in 1,000 times 1.2 raised to the x. But now x is going to be 0. If I plug 0 in, do I get 1,000 to go with it? So it gives me that first order pair, right? If x is 1, do I get 1,200? Which would have been this, I don't know why it deleted, but would have given me that y value right there. If I plug 2 in, does it give me 1440? If I plug 3 in, does it give me 1728? Yeah. So it's another way of getting what's in that table, right? But if you remember getting that table, I had to do, multiply. And let's say I want to figure out what is the number of cell phone users at year 10. Well, if I'm going to use just the table, I have to know what they used at 9, right? I have to know how many cell phone users there were at year 9. Well, to do that, I need to know what was at year 8, right? To do that, I have to know what was year 7. I have to look all the way back and basically have, if I want to know what year 10 is, I have to know what the data looks like for years 0 through 9, right? But if I know that 0 through 3 are showing me exponential, now if I want to know year 10, the idea of having this formula says in year 10, that's how many people are going to be using cell phones. Does that make sense? Okay. Or if I want to go year 71, that's how many people are going to have cell phones. Does that make sense, everybody? Okay. Now there might be, so this is, year 71, is that really legit? Is that something that we're going to do? Probably not, because 71 years of technology, there's probably something that's going to change that's going to probably make people either use cell phones more or use them less, right?
Yeah.
Okay. When cell phones first came out, when I was in middle school, cell phones were coming out. They were,
Hey, you're old.
they were like the size of this thing. Like they were huge, okay? And so not like, and they were expensive. They were like several $1,000s. And eventually they started getting more compact, smaller, cheaper. And now everybody's got one, right? Okay. So.
Do they look like this?
No.
They didn't?
But they had like the first one that like my parents had was like seriously, it was huge. It was like the size of one of these things, and the screen was green, and it had black pixels. It was a lot like a TI-83 or 84 screen, but it was a green like backlit screen. It was ugly. Okay, you guys ever watch Saved by the Bell?
No. Wait.
You guys don't know what Saved by the Bell is?
I don't know what that is.
I done heard of it.
So Saved by the Bell was a TV show, and I was growing up. Always played it, or it was always playing at the beginning before school. My sister always had this on TV. Let's see here.
Who sneezed?
Like you've never, I can't. You seen this stuff, Saved by the Bell?
No.
These people? All right, so Zach, this is Zach Morris. He had a cell phone. Let's see if we can get Zach Morris's cell phone here.
Zach Morris.
What is this, Zach?
I might have once. I seen.
Yeah,
All right, so those were like the first cell phones. Okay. But so think about from now. So that was when was Saved by the Bell? Saved by the Bell. Started in 1989. Okay. To 1993. So we're looking at what 30 years. Okay. Look at what happened by technology in the duration of 30 years. Right. Went from that thing that had absolutely all it could do was call to now our phones currently, right? Think of what's going to happen in just the next 5 years with cell phones, 10 years, 20 years, okay? So if I put 71 years on here, okay, that's probably not realistic for this situation because that number will probably, because of technology, that 20% will probably fluctuate over the next 70 years. Does that make sense?
Way different.
Okay. Okay, so that problem out of Math Excel. Okay, I want you guys to kind of see. I think not only is it important to learn this stuff, but have an understanding why maybe your teachers give you the assignments that they do. Maybe creates maybe a little bit more purpose to those assignments. This question right here is a question that's pulled off of last year's, I think it was last year's or the year before, in a course exam. Okay, every year, the state of Ohio will release a handful of their test questions. This was one that was released a couple years ago. Let's read. It says, a scientist is studying wildlife. She estimates the population of bats in her state to be 270,000. She predicts that the rate, she predicts the population to grow at the average of 2.9%. An annual rate of 2.9%. Okay? Do me a favor here. Think about the question we just did. Talked about cell phones, right?
Yeah.
Delete where it says she estimates the population of bats in her state and put in she estimates the population of cell phone owners in her state. Is it the exact same question?
Yes. Right.
Yes. Okay? But now look at what they give you. You are going to type your answer in right here. This is like a screenshot off the computer. When you take that test, that blue box is all you're going to see. You're going to have that keyboard, all that kind of stuff, and that's it. Okay? There's no part A that says fill in the chart. There's no part B that says ask yourself, is this Common difference, common ratio. There's no part C that says, well, once you've done that, is it exponential or linear, right? It's just asking you to go from that statement to an equation, okay? But in order to do that, you have to do exactly what we did over here, okay? So I want to go through this with you and figure this out, okay? So, there are some things that you can recognize. So I know, and I've done this long enough that I know that my common difference is going to be, my common ratio, I guess I don't want to say common difference, common ratio is going to be 1.029. I know that for certain. That's going to be my B value. But I want to show you how you guys can realize that, okay? So, think about the last question. Wasn't our common ratio 1.2? Where'd that 0.2 come from in the question? It came through, so the 1.2 came through dividing the y values, right? The successful y values. But look at the 20%.
Yeah, that's what I said.
The 20% is what was actually contributing to that 0.2. Does that make sense? Okay. So, if I look at, so times 0, she is going to estimate that she has 270,000 bats in her population, right? Okay. It would really stink for some of us, especially those of us maybe on this side of the classroom, that if I were to ask you tomorrow on a test this question, and you have no notes or anything that you could use and look at and help yourself with, right? Get stuff out, guys. I'm not just sitting here spewing all this information out to you just because I like to talk about exponential functions. I'm trying to help you, okay? I'm trying to teach you something. Help yourselves, okay? While you're doing it on top of that, okay, some of the conversations that happen while I'm teaching and the giggling and the laughing and that kind of stuff, and look at each other and make faces and sign language, that stuff's got to stop, okay? Because you're going to reap the benefits of that when you take that end of course exam and you get a 1 or 2 on it, and you got to take it again next year, you got to be in the same classes next year, and you have a remediation math class next year on top of that because you got a 1 or 2 because all you want to do is screw off the class. Does that make sense? Okay? So help yourself, okay? I can't stress that enough, that you don't want to put yourself in a situation where you've got to take that test again. And I'm going to be blatantly honest with you, it's not an easy test, okay? I think this is a hard question, okay? And it is very likely that this question or a variation on it will show up for you. All right, so that is the initial time. That's her initial prediction. Says it has a growth rate, an annual rate of 2.9%, okay? And it's going to grow. So when it says grow, that means I'm adding 2, right? You could maybe experience a question where it says that maybe you have a population that's decreasing. So it would have like a decay rate, okay? And then that would just tell you that you're subtracting, okay? But when we, let's see here. When we take that 270,000 and we're going to multiply it by 2.9%, and then you're going to add that to that 270,000. Yes. There we go. So 270,000, and then go 0.029, right? So gives you that number. And want to add that number then to, what'd you multiply by?
I multiply by 2.9.
Okay, so you got to move your decimal. So that's a percentage. So when I multiply by percents, I got to actually change it to a decimal, right? So we got to move the decimal place 2 spots. Which question? Okay. So 2.9% is actually that through our calculations.
Wait, so you would just move it to the left?
Yep, two spots. So then, go ahead. I want to add those 2 numbers together, right?
We definitely did not get the same. Come on. Look. See how it's like 3? And this one?
Point 0 2. You got point 0.
Oh, she was so.
So now, right here, we're gonna have 277830, right? Year 2, I'm going to take the previous number of 277830 and multiply it again by 0.029. Now I'm going to add that number to 277830. And I get that amount. So that's how many bats that I'm going to have. Okay. Now, obviously, the 0.07 in regards to like live things doesn't make sense, right? But that 2.9% will generate values that are not just whole numbers, which is fine. Okay. So now to find year 3, and we can go as far. We really don't need to go any further than this, but I can go to year 3. And I can go, so the previous number, I'll just cut and paste this, times 0.029, gives me that. And I want to add that number then to so it gives me, in year 3, our bat population is going to be that. Okay? So now the question is, once I have that table, how do I find my common ratio? Okay? Now, if I gave you a table, I think I did this yesterday. We had a table like this was like 0, 1, 2, 3. And I went from 5 to 25 to 125 to 625. That's pretty easy to see what that common ratio is, right? Because I know we deal with these numbers a lot that, okay, 5 times what will give me 25? Well, that's times 5. 25 times what will give me 125? Well, that's times 5, right? Do you know what number you're going to multiply 270 by, or 270,000 by, to get 277,830? You don't know that number off the top of your head, right? So what you're going to do is you're going to take 277,830 and you're going to divide it by 27000, right? Or 0. Does that make sense? Okay, because if I didn't know that 5 times 5 was 25, I could have taken 25 divided by 5, gives me 5, right? Or I could go 125 divided by 25, gives me 5. So we see that 1.029 is that ratio between these first two numbers. Let's look at the ratio between the next two numbers. Let's take 285,887.07 and divide that by 277,830. What's that give me? 1.029, same number, right? If I go 294,177.795 divided by 285,887.07, 1.029 again, right? So what is my common ratio that I'm recognizing here? 1.029. Now think about this. Why is it 1.029? Isn't this number 100% of that number plus 2.9% of that number? Does that make sense? So isn't, if I go 100% as a decimal, would be that number, right? 2.9% as a decimal would be that number, right? If I add those together, it's my common ratio. That makes sense? Okay, so that's the B value. That's the B value. So I'm going to write the equation y equal, we know it's exponential because of the common ratio. We're going to go y equals A times B to the x. We now know B is 1.029. 1.029. Okay. Next thing we're going to do is try to figure out what is A. Well, from this information, to find A, just like all the other examples I gave you, we're going to insert that ordered pair, right? So when y is 270,000 and x is 0, what is going to happen to this thing right here when that exponent is 0? Turns into 1. So what is a going to be then? So that's a, right? So then I write my formula, y equals that number times then 1.029 raised to the x. And that, guys, is the thing that you type in to see if you've done the problem right? That's what they're grading you on, okay? You see that there's a vast amount of places where you could go wrong here, okay? A lot of people go, I mean, you guys, somebody said you use 2.9 as your multiplier, right?
Yeah.
Okay? If you make that error and you could do everything else right, that error makes everything wrong, right? Okay? You would end up with 1.29 as your b value. Or actually, I think you'd probably end up with like maybe 12. You'd end up with, I don't know, maybe, I don't know, probably 12.9, something like that, as your b value. So somehow you would have an error with your b value, but everything else would be maybe the same or be correct. Does that make sense? Just be cautious of that.
When you were trying to figure out what the ratio was on the writing, I
Yes.
just got totally confused with how you remember it.
Okay, so like you know, and this is where guys, the understanding the relationship between multiplying and division I think is important. Let's say that we get to the test and they give us this chart here. So I'm going to just put 0, 1, 2, 3, and 4. Okay. Don't write this down, but if I, like I said, let's say I put 4 here, and then I put 16, and then I put 64, and then 216. You might be able to see, what am I multiplying 4 by to get 16? 4. What am I multiplying 16 by to get 64? 4. What am I multiplying 64 by to get 216? 4. So there's your common ratio, right? Okay. So, but what if we're on the test and the test has a chart filled out for us already, but it's not a nice chart like that? So give me 1 second here and I'll come up with. Okay. So let's say that we get to the test and they have a chart filled in for us and they're asking, okay, they're telling us this is exponential, and we got to figure out what that common ratio is. If I go, and just like the last one when I put the, the 0 to 4 and 1 to 16, 2 to 64, you could see that times 4, right? Can you see what you're multiplying by here to get from 245 to 573.3? No, okay? But if I know I'm multiplying by something to get, this is my product, right? This is one of my factors. How do if 573.3 is my product and 245 is one of my factors, how do I find the other factor? Divide them. Does that make sense? So I'm going to start with, and the same thing happens here. If I get 16 and divide it by 4, does that give me that 4 that I used?
Yeah.
If I take 64 divided by 16, does that give me my 4 that I used?
Yeah.
So if I go to Desmos real quick, and we divide these things out, so I'm going to take 573.3 and divide it by 245, gives me that number there, right? Now, I'm not maybe confident that this is exponential. So what I'm going to do is I'm going to go, well then 1341.522, let's divide that by the number before, 573.3, does it give me 2.34? That kind of, so we're seeing that 2.34 is then the number that I'm multiplying here to get the next number. And that then would be my b value. Does that make sense? So when y equals a times b to the x, I'm going to have y equals a, b is 2.34 to the x. Now, hopefully maybe you've been seeing this, and this pattern only works if we've got the ordered pair 0, 1, or sorry, not 0, 1, 0, whatever for our y value. Every time we've done this, hasn't our a value ended up being that y value right there? And we can go through all the problems we did yesterday and the one we did today. But that might be a shortcut to get that that A value, because if you see, the one we just did, isn't the A value for our equation that 270,000? Yesterday we come down here. Here was one of our exponentials, and here was the equation 4 times 2 to the x. But the A value is that 4. This one, the equation is y equals 3 times 4 to the x. But isn't that A value that 3? That kind of makes sense to everybody? So but that's only if they give me the 0 for the x value, that I can make the y value the A then in the equation. So, okay? I'm gonna give you guys a few minutes here. And this is another end of course exam question. I'll wipe this out. And all I want you guys to do is analyze that statement and come up with the exponential function y equals a times b to the x. We know it should be exponential because whenever it says the word population, I don't want to say populations are always 100% exponential, but that should kind of get the ball rolling. It should send a light bulb off and say, that's probably exponential. Then it says it doubles. So whenever it says something like doubles or triples, or gives you a rate of increase like 2.9%, or something like that, or 20% from our homework, that is an identifier that this thing's going to be exponential. Okay? So what I want you guys to do is go through, create a chart of x's and y's here. We'll just go down to 4 or 5 x values, 0, 1, 2, 3, 4. You find the y's. And once you find the y's, determine what the b value is, and then write down what your equation would be for this exponential situation. If I multiply by 2 to double, as a percent, 2 as a percent is 200%. Okay? So when something doubles, we're actually using 200%. So if you're going off the idea of what we were doing in the last questions, like the answer was, like the last one was 2.9%, right? We changed that to 0.029, and then that added a 1 to it, and that was our B, right? So if I know doubling is 200%, well, as a decimal, that's 2.0, right? Add 1 to that. All right, in this case, I'm not going to add 1 to that, so never mind. But that then would be my B value. Does that kind of make sense? Yeah. Be careful with the word double. The doubling for us is multiplying by 2, and we're not going to be doing the percent thing here. I think that's the best way to think about it, is not to use percents in this case. What does our chart look like? What's this first y value with 0? 150, 300. Okay, good. So then what is that common ratio that we're seeing each time? Times 2, right? And that is that double, right? So if that double said triple, what would it be? Times 3. If it said quadruple, it would be 4. What if it said it halves? Okay, so it would be, so if I say half or halves something, through multiplication you're multiplying by 0.5 or 1/2. Okay, so that's something to think about with certain things. Have you guys in science talked about radioactive material?
Yeah.
So if I have like uranium, okay, let's just talk about carbon. Okay, carbon-14 is essentially radioactive. Okay. Basically, it says if there's this much carbon in something, we know, I don't want to say radioactive, but it has what we call a half-life. If carbon-14 is sitting in a current state, let's say we have 100 grams of it, in 5,000 years, that will have disintegrated to just 50 grams. Does that make sense? It's called a half-life, okay? Those are maybe things or words to kind of think about when we're using exponential. Doubles, triples, halves. But now, so my B value would have been what? 2, right? What's going off the pattern we used in the past? What's my A bet value going to be here? 150, okay? So we get the equation y equals 150 times 2 to the x. Now look at these examples here. It says which one of these will tell me that I'm going to get a population of 400 or 4,800. Which one of these makes most sense? D makes most sense because that right there is what we just came up with right there, right?
Yeah.
Okay. Remember, test tomorrow.
Test tomorrow?
Yes.